This is setting up an experiment in Diva when using the HTS on the Fortessa X-20. So the HTS, or high throughput system, it's for automated acquisition using 96 or 384 well plates. First thing we want to do, same as with all of our instruments, you want to scan the QR code and log in using our iLab kiosk. The directions are on the paper. Now we're going to make sure that the instrument is set up correctly in plate mode. And this will be done by core staff. If it's during business hours or if it's after hours, then a trained user will be able to do that. And we do have a video on how to set it up in plate mode and how to return it from plate mode back into tube mode. So first thing we want to check is the configuration in the software. So up at the top it says what the configuration is, and we want the configuration that says HTS. So this does not say HTS. We're going to go to Cytometer, View Configurations. We're going to select the HTS and set configuration and OK. If you're using the HTS, you need to run CST in the 96 well plate using the HTS, and you would just do that normally, except that you would uncheck this. But so now it is in the correct configuration. We will close this. The next thing we want to check is that the switch on the side is pointed towards plate mode. So plate mode, tube mode. So it is indeed in plate mode. The next thing we want to check is that the sheath line, this one right here, is plugged in. Sometimes people forget to plug it in after they return it to tube mode, and it's very important that this is connected. If this is not connected, the sheath doesn't get pumped through the HTS, and you will introduce air into the system, which is a big problem. Next, we're going to make sure that the sheath probe is in the white sheath box, which it is. Okay, that's our alarm. This is the sheath with surfactant, and it's recommended for use when using the HTS. Next, we're going to check to make sure there are no red lights. If you see a red light, you need to hit restart. And make sure the Fluidics cart is on. This is what it looks like off, no lights at all. You want the cart on. When a green light, no red lights. So everything is now set up properly. We're going to talk a little bit about sample prep. It's really important to make sure you have enough volume in your wells. For the 96 well plates, that is 250 microliters. If you're using standard mode, which we'll discuss in a moment. This 250 microliters, 200 is the maximum volume that you can use, aspirate for analysis, and then there's a 50 volume excess, which accounts for a plate-dependent dead volume and an aspirated excess to prevent air bubbles. So please make sure your wells have at least 250 microliters for 96 well plates in standard mode and 50 microliters for 384 well plates. You also, in addition to your samples that you want to analyze and record, you need to include setup wells. Setup wells you will acquire without recording, and use these wells to adjust the voltages. These will be unstained to look at the background, and fully stained samples to make sure that all your data is on scale and adjust forward, side scatter, and fluorescent parameter voltages. So with the software, we've already logged into the computer, but the login and password for the computer are posted on the cytometer. Open the software and log in to your login. And I've already set up an experiment, created an experiment. If you have a template, you can use a template, but we're just going to open this experiment. And we're going to, this is all the same as in the plate tube mode. This will preliminary work of, you want to make sure that height and width of the forward and side scatter are checked. You want to delete all unwanted parameters, or alternatively you can delete everything and just add back what you want. We're also going to start these voltages at 200, because these are more suited for cells. The fluorescent voltages we're not going to change until we run our setup wells. And these should be set based on your cells, making sure all your data is on scale. Now what's different, we're going to go to the plate layout, new plate. So if you click the down arrow here, you can see the different types of plates that are available. U-bottom, V-bottom, flat bottom, and 384 flat bottom. So what we're using today is a 96 well U-bottom, and just a note about the flat bottom plates, BD in the manual says that mixing efficiency is less in a flat bottom plate. Alright, so we've opened our plate layout, and the first thing you want to do is make sure that you are in standard mode. Now we're going to add our setup wells, which is, you click and drag where they're located and click the pink button. These are your setup controls. If you want to change the name, you can change it here. We will leave it as is. We're going to highlight these and adjust the settings. So the sample, here are the loader settings here. So the sample flow rate has a range from 0.5 to 3. You want it the lowest flow rate for your setup wells, so we'll leave it at 0.5. Sample volume for your setup wells, you want the maximum volume. We will leave that at the maximum of 200. The range is 2 to 200. And remember, have 50 microliters more in your well of whatever you want to, the sample that you want, amount of sample you want analyzed. The mixing volume should always be half of the sample volume. The mixing speed, the range is 25 to 250. The default mixing speed is fine. If you have fragile cells, you might want to decrease the mixing speed. The number of mixes range from 0 to 5. Increasing the number of mixes will take your plate longer to finish. The default number of mixes is perfectly fine. The wash volume is just the volume that it uses to rinse after one sample has run. The default is also fine on that. BLR means baseline restore. That's just a short period of time before, it is an initial period of time delay before recording begins after acquisition begins. So if you use it, it will add a little bit of time to your plate, but it also allows a little bit of time for the Fluidics to stabilize. It's up to you whether you want to use it or not. We will go ahead and use the maximum. The numbers here, 5 to 150, if you multiply by 10, so 50 to 1500 milliseconds is what it adds. So it's not a lot of time. All right, now we're going to add our samples, our specimens, by clicking and dragging where and these specimens can be used as groups. So we'll click the specimen button. Now we will select all of these and set the loader settings for our samples here. So the sample flow rate, I'm going to put it somewhere in the middle. Again, this is dependent on the concentration of your cells. You want to keep your event rate below 10,000. You just want to make sure your resolution is not compromised by a flow rate that is too high. Sample volume, we're going to go with 200 max, because we want to extract all the data possible. Mixing volume, 1/2 of the sample volume. We're going to leave these three as the defaults, and we'll just leave off the BLR. Now, I do recommend, if you want to run compensation controls, just create a specimen and just run them as samples without calculating compensation beforehand. It's just easier that way. So these loader settings, if we highlight all of them, we see they're not all the same here. These red boxes indicate that everything doesn't have these settings are not the same. So we can copy the loader settings, and if we select these, we can paste the loader settings here. You can also drag these wells around the plate and put them wherever you want. All right, we're going to leave our plate layout open here, and we're going to go to the experiment layout briefly. Experiment layout, and here's where we're going to label our fluorophores. Let's see, I'm going to add a new label for this one. I'm going to call it Live Dead. Add to list. Going to now select it and assign it here. This one I'm going to say that it's Alexa Floor 488. So we're going to add that to the list and assign it. Now, oops, I picked the wrong one. So we're going to remove that one and add it right here. The next tab is keywords. You can add any keywords that you like. I'm not going to go over that. We went over it in our previous video. But I do recommend, and this is tedious, but I do recommend that you buy the well ID, keep the well ID, and then say what is in this, wild type spleen 1. So now you know exactly what is in that well. It's not just D1. So you've attached some important information to your file. We won't go through the whole thing, but if you just click once then you'll be able to type in this box. And I do recommend that you use the acquisition tab of the experiment layout. First, you have to choose the global worksheet by clicking the column header, clicking the global worksheet, and then for our setup wells, we want to make sure that this is on the highest number we have so that it won't run out. And then the stopping gate doesn't matter, it's just going to keep running until it, and then the storage gate, you always want to store all events, all of your data. For our specimens, you can set these based on a gate, right? So you could choose single cells to collect a certain number of single cells or some other meaningful metric. That's why you have to already have your gates. It could be CD45. So you could, collect maybe 50,000 single cells. Or if you just want to collect the data from all 200 microliters, you just set this number at the highest number available, and any stopping gate, it doesn't matter. It will just run, because it's not going to reach 10 million events. It will run the amount of time, which is the sample volume divided by the flow rate. So on hours, so we'll save this. On ours, the sample volume is 200 and the flow rate is 1.5. Or if it were 2, 200 divided by 2 is 100 seconds. So you get the idea. So it's the sample volume divided by the sample flow rate will give you the number of seconds that your sample is going to use. So now we're ready to run our setup wells. And just check your settings one more time to make sure everything is the same. There's no red boxes, so we're ready to go. We're going to put the instrument in run mode. Load our plate with A1 in the back left corner. Replace the plate. We're going to get our cytometer window up so that we can adjust the voltages. Now we're going to run wells. We're just going to run this one well. Now if you don't see these plate controls, if you right click, it will say show plate control. So if we hide that, it's gone, and then we got it back. So we're going to run this setup well and adjust voltages. So it takes it a few minutes to get started here, but you can look at plate status and it will tell you what it is doing. So today I'm just running some beads, but I'm going to adjust the side scatter down. And I'm going to adjust the forward scatter up a little bit. You see our brightest dye is on the axis, so I'm going to adjust that downwards a little bit. maybe a little bit more. We look at everything else and everything looks on scale. It's just going to keep running until it runs out of sample. We looked on our plate. It's 0.5 microliters per second with 200. So this would run for 400 seconds if we didn't stop it. But we're going to go ahead and stop acquiring, and since we were able to set our voltages with just one well, we're not going to run the other well. So I'm going to stop acquiring and stop the well. And I did forget to mention that before you start running your plate, you can use the shaker, which is by the Curiox. This one, if your cells tend to settle to the bottom of the well, just give them a quick shake before you run them. This mixes your sample, but it doesn't aspirate from the bottom of the well. There will be some left in the bottom of the well. If something is wrong and you need to stop the plate, what we recommend is using pause instead of stop. So if you, we'll demonstrate that. So now we're going to tell it to run the plate. And I'm just going to turn the flow rate up to 3, just so it will go faster today. We're going to say run plate. So once your voltages are set, you can just run the plate. And you see when you tell it to run the plate, this pause button is now live. So you have stop well, stop plate, or pause. So if you click pause, and also it will start wherever you're had highlighted. So we missed this well, but it will not go back and get it. So you would have to run that one separately once it's finished. So if we hit pause, then it's going to finish this well, and then it will, you can do whatever you need to do, and then when you're ready to continue the plate, you will hit resume. If you stop the well, then it discards the sample and you've lost it. All right, so it ran that sample. And now it's just waiting for us to, now you can stop it. If you needed to change the settings, then you could do that. But we did get all the data that we wanted out of this well. So now if we realized that the flow rate was too high and we wanted to change it to a lower flow rate, we could do that here. And you also always want to have a time plot. So time versus any fluorophore, doesn't matter. And if you go to the inspector window and you auto scale time parameters, we use the cumulative display. Why won't it let me? Then if there are gaps in this plot, then you can that means that you're having a problem with air bubbles, so maybe you might need to add some more buffer to your wells. So that just gives you an idea. Or if your sample is clumpy, creating, clogs and causing gaps in your data, then that's something maybe you need to stop it and filter your samples. All right, we'll just start here, and we'll say run plate, and then we'll stop the plate so you can see the difference. So here's your time plot. You see there are no gaps. The gaps will be vertical gaps in the data. So this looks good, but if you had air bubbles, then that would show up here. So if we stop the well, or stop the plate, so it stops instead of finishing running this well, it stops, and you've lost any further data that would be recorded. You just discarded the rest of your sample. So you would just, start from your first well and then let the plate run, and then when it's done, we have to run a clean plate. So to run a clean, you go to HTS and clean, and just click OK here. You're going to load a plate with rows A1 through 4 with 10% bleach, B1 through 4 with water. So you just load that. And then you hit OK, and then that will run. It takes about 10 minutes. Then when you're finished, when the cleaning is done, you can export your data. I right-click, export FCS files. It's grayed out now because it's busy doing the clean, but you can export them before you run the clean. So right-click, export FCS files. And then if it's during business hours, core staff will return the instrument to tube mode. If it's after hours, then you should be a trained user and know how to return it to tube mode, and we also do have a video on how to do that. And that is setting up a plate mode in Diva.